Hey everyone, this is Mrs. Kostelecki. Welcome to AP Stats. Today we will be talking about the difference of two means and a sampling distribution. So if you have two samples that are means and you want to subtract them, then this is your process. So I'm going to start writing these notes out here. We have the sampling distribution of x bar 1 minus x bar 2. So the x bars, remember, those are going to be your samples. So if you have two different samples, one of them would be x bar 1 and the other would be x bar 2. The first thing you have to assess is the shape. Of course, we always want them to be normal if we can. And very important reminder, you have to check both sampling distributions. Okay, you are taking two different samples, so you have to double check to make sure both of them are approximately normal. Now, first thing you can check is if the population for both x bar 1 and x bar 2 are already approximately normal. If their populations are normal, then the samples are also going to be normal. So if, double check that. They give that to you, great. You have less work that you need to do. But they often don't. So your other option is if your sample size is greater than or equal to 30. And so by the central limit theorem, your sampling distribution is going to be approximately normal. So you have to write that down. You have to write down either that the population that both samples came from are approximately normal, or if you don't know that, then if you know the sample size is greater than or equal to 30, you have to check that off for both of them. Make sure to do that. Your center, okay, we're going to need our center because it's a normal distribution, so we need the mean. The mean of your sampling distribution for the difference of your means is the mean of x bar 1 minus x bar 2 equals the mean of 1 minus the mean of 2. So the first one here, this would be coming from your sample. The other one, this is going to be your population. So basically they're saying the mean of your sample, the difference of your samples, is going to be the same as the mean of your population. So hopefully you have the mean of your populations. Your variability, that's going to be your standard deviation. So the standard deviation of x bar 1 minus x bar 2 is equal to, and very similar to with proportions, we're going to take that formula for one mean, which was the standard deviation over the square root of n, but we have it under a square root already, so it changes it slightly. It's going to be the standard deviation squared all over n, and this would be coming from the first sample, so we're going to use ones, plus the standard deviation squared of your second sample all over n2. And I made that line ridiculously big, so let's change that a little bit. There we go. Okay, so there's your formula. Now, these formulas are on your formula sheet to use. You don't have to memorize them, but you do need to know how to use them correctly. Also, I do notice that the square root sometimes gets a little goofy, where some people will just put that on the top and they forget about the bottom. Make sure that you know that this whole formula is under the square root. Okay, the whole point of that, if we can check off, yes, the shape is approximately normal. Yes, we have our center. Yes, we have our variability. Now what we can do is we can make our normal distribution. So normal calculations. This is kind of the same process, same thing that we did with checking the binomial distribution. If we can approximate it with the normal distribution, it's the same thing as we have one proportion or if we have one mean. Now we just have two means. So here's our normal curve, n, and then we're going to put in the mean of our x bar minus x bar, so 1 minus 2, and our standard deviation of x bar minus x bar, first sample, second sample. All right, so you're going to label your normal distribution. Your mean is going to end up being whatever x, sorry, I shouldn't use an x there, whatever mean of 1. So the mean of 1 minus the mean of 2, that's going to give you your mean. And then your sample is going to be the x bar 1 minus x bar 2. And typically normal distribution shaded to the left. If you need it to the right, then you do the 1 minus your area. But your z-score formula. So it still is value minus your mean divided by your standard deviation. But now that we have all these fancy formulas, it makes it a little bit more complicated. So we're going to take our samples first. x1 minus x2, so our x bar samples. That's our value, so this is what the difference of our samples would be, minus the difference of our actual mean, our proportion means, divided by our standard deviation formula, so that's just this formula right here. So we're going to do standard deviation squared divided by n plus standard deviation squared divided by n, and that's your first sample, and this is your second sample. Whoops, that's a 2. Okay, so same process. You have to check to see if it's normal, approximately normal, always approximately. You have to find your center, you have to find your variability. That allows you to get your z-score, and then you can calculate your area from there. So definitely start seeing these patterns so that you don't have to look at them as individually different. It's always the same process. It's just that sometimes you're using proportions, sometimes you're using means. There is definitely a difference in checking your shape. So for proportions, you have to use the n times p is greater than or equal to 10, n times 1 minus p is greater than or equal to 10, where for means, you check to see that your sample size is big enough, that it's greater than or equal to 30 by the central limit theorem. All right, I'm going to end the video here. Good idea to start that check your understanding and put it into practice. See if you have any questions. Thanks for listening, everyone.